You may have seen this equation in class, but to prove it, we need to think a little deeper. When you think of trig functions like sine theta and cos theta, the first thing that comes to mind is triangles like this. For simplicity, I've used a hypotenuse of 1. This means that this side here is sine theta, because sine theta is the opposite of the hypotenuse. The hypotenuse is just 1, so this side is sine theta, and similarly with cosine of theta being the adjacent over the hypotenuse. But what if we wanted to visualize how this triangle changes as theta changes? If we wanted theta to go from 0 to 360, bringing this hypotenuse round with it, it would draw out a unit circle like this, which is actually how sine and cosine are defined. Now the next logical step would be to find an equation of this circle. For simplicity, we've placed the circle with the centre being 0, 0. We know that the radius of 1, so that if you think back to GCSE maths, the equation of this circle will be x squared plus y squared is equal to 1, which is the radius squared. 1 times 1 is still just 1. We can quite clearly see that the x component of this circle is equal to cosine of theta, and the y component is equal to sine of theta. This means we can write these two equalities. X is equal to cosine of theta, and y is equal to sine of theta. Plugging this back into our equation of the circle, we get cosine of theta squared plus sine of theta squared is equal to our radius of 1. This is written as sine squared theta plus cosine of squared theta is equal to 1 for simplicity, with the 2 being above the sine instead of in a bracket and then squared. These two are exactly the same thing, they're just written in slightly different ways. To add on to the notation that we use to write this identity, sine to the minus 1, or the inverse of sine, sometimes written as r sine, is not equal to sine theta in a bracket to the minus 1. The other identity you may have heard of is sine theta over cos theta is always equal to tan theta. This is not really something that can be proven, as it's by definition.